Okay, the size of any angle in a right angled triangle can be found if the lengths of any two sides are known. We just use our knowledge of our trig ratios. So let's look at the examples that we have here. I'm going to write down SOHCAHTOA just to remind us so we can always refer back to that SOHCAHTOA. In this first triangle, opposite to the right angle is our hypotenuse, opposite to our marked angle is opposite. So in this case we have opposite, we have hypotenuse, so we use our sine ratio. This is different to what we've done before because it's the angle that we don't know. So we write the sine of the marked angle, and that's what we don't know, that's what we're trying to find, is equal to opposite on the top, hypotenuse on the bottom. So that's our trig ratio. So the sine of our marked angle, if we do 3.5 divided by 5, it's 0.7. Just as inverse operations are used to solve equations, inverse trig ratios are used to solve trig equations for the value of any angle. So in other words, we're trying to find the angle. What we want to do is we want to find the angle. We want to leave this here. So we need to move the sine to the other side. When we move something to the other side, we do the opposite of it. So how we write doing the opposite when we move sine, it's sine to the -1. So that's how we write, that's the inverse of sine, sine to the -1 of 0.7. Then, how we actually find this angle. Into your calculator, to find the angle, sine -1 means you go shift sine. So into your calculator you go shift sine and then 0.7. That will give you an answer that theta is equal to 44.427004. It wants it correct to the nearest degree. So on your calculator you press the degrees, minutes, seconds button. So theta is equal to 44 degrees, 25 minutes, 37.21 seconds. That's degrees, minutes and seconds. It wants it to the nearest degree. So let's look at our degrees. That's it. Look at the thing after the degrees, which is the minutes. Now, 30 is your magic number here. 30 is your halfway mark, like 5.5 is when you're rounding off decimals. So if this is less than 30, the 44 degrees stays as 44 degrees. So theta is approximately equal to 44 degrees. Let's look at our next example. So what we have here, we have information about the opposite and information about the adjacent. So if we have information about opposite and adjacent, then we use our tan ratio. And we write the tan of the angle we're trying to find is equal to opposite over adjacent. So tan of theta equals 5 over 11. We want to move the tan to the other side. When we move something to the other side, we do the inverse. So it's tan to the -1 of 5 over 11. Putting that into your calculator, tan -1 is shift tan. 5 divided by 11 is equal to, so theta is equal to 24.44395478. Putting that in terms of degrees, minutes, seconds, you press your degrees, minutes, seconds button, 24 degrees, 26 minutes, 38.24 seconds. Rounding off to the nearest degree, let's look at the thing after the degrees. It's 26 minutes, which is less than our magic number of 30, so theta is approximately 24 degrees. Okay, a couple more on this triangle, or one more, sorry. Let's look at the marked angle. What do we have information about? It actually tells us. It tells us that this is the opposite side and this is the adjacent side. So we have information on opposite and adjacent. So once more, it's our tan ratio. The tan of our marked angle is equal to opposite on top, adjacent on the bottom. We're wanting to find the angle, so we need to move this tan to the other side. The inverse of tan is tan -1, 7.2 over 3.1. So in our calculator, shift tan, 7.2 divided by 3.1. I put brackets there just to remind you that's what you do when you put it in your calculator. So our angle is equal to 66.705436675. Let's put that in terms of degrees, minutes, seconds. Our angle is 66 degrees, 42 minutes, 19.57 seconds. So correct to the nearest second. It asks us first of all, correct to the nearest second. So we look at our seconds. Do we round that? Do we say it's 19 seconds, or is it more than halfway, which 0.5 is? Do we say it's 20 seconds? So we round that up to 20 seconds. So for part A, if we were asked to round it to the nearest second, it would be 66 degrees, 42 minutes and 20 seconds. Part B wants it to the nearest minute. So I'll just write it down again. 66 degrees, 42 minutes, 19.57 seconds to the nearest minute. So you look at what's after the minutes, which is seconds. Our magic number being 30 seconds. The halfway mark there is 60 seconds in a minute, so the halfway mark is 30. That is less than 30, so this 42 stays as 42. So the answer, this angle to the nearest minute, is 66 degrees, 42 minutes.